Okay, in this video we're going to look at horizontal asymptotes and the idea of infinite limits, which simply means x is approaching infinity or negative infinity. So we're looking to essentially answer the question, as x approaches infinity, in other words, as x gets really big, or as x gets really small. Alright, something like 1,000,000 or something like negative 1,000,000. What is ultimately happening to y? What we're going to see is that many times it will level off and it will approach a fixed value. Let's take a look at some examples. Okay, in this first example we have y equals e to the x. It's graphed for us. Now in this situation, notice that first, if we start over here on the right hand side, as x gets really big, y is also getting really big. Okay, so it's not leveling off there. However, on the left hand side, as x approaches negative infinity, so we're talking about this portion of the graph, notice that y is approaching 0. So we say that we have a horizontal asymptote at y equals 0, because as x approaches negative infinity, y is approaching 0. So we say we have horizontal asymptote there. Okay, in our next example here, we have the same function that we saw in the last video. We know that there's a vertical asymptote at x equals 2, and I want to talk about why there is a horizontal asymptote at y equals 1 here. Well, if we were to break this down, if we were to think about as x approaches infinity, imagine taking this function and plugging in something like 1,000,000. Okay? If we plug 1,000,000 in for x, we'd have 1,000,000 divided by 1,000,000 minus 2. Well, that minus 2 is not going to have much of an effect on things. So you essentially would have 1,000,000 divided by 1,000,000. So y would be approaching 1, since anything divided by itself is 1. Likewise, if x were to approach negative infinity, so if you were to plug in negative 1,000,000, once again we would see that y is approaching 1. So because of that, we say that we have a horizontal asymptote at y equals 1. Okay? Alright, so we're going to summarize our rules for horizontal asymptotes. And these are usually going to show up when we have a rational function. So a function divided by a function. So the fancy name for this is power, function, and behavior models. So the idea of a power function, well, you have x raised to some power, and by end behavior, this refers to the extreme ends. So the left extreme end would be as x approaches negative infinity. The right extreme end would be as x approaches positive infinity. So if we look at this function that is given to us, if we wanted to determine as x approaches infinity, what is happening to y? Well, if I were to plug in 1,000,000, we really don't care too much about this plus x or that plus 8 or this plus 1, because the powers are less than these main terms, which sometimes we say these are the dominant terms. So as x approaches infinity, if we plug in something like 1,000,000, alright, y, well really, we need to look at just this y equals 4x squared over x cubed piece. And by the way, this is what we call the end behavior model. Okay, just that piece right there. In other words, we just need to plug into that. Again, if we're plugging in something like 1,000,000, those terms with lesser powers are not going to have a great effect on what is happening to y overall. So if we get back to what's happening to y, if I were to plug in 1,000,000, square it up top, and then multiply it by 4, and then on the bottom cube it, notice that the bottom has more weight. So if you're dividing by something that is much bigger than your numerator, in the end you're going to get something very close to 0. So if you have one pizza divided by 3 billion people, you're going to be lucky if you get a crumb. So the same thing would be true as x approaches negative infinity. Y would also be approaching 0, so if you were to plug in negative a million, you would again get something very close to 0. So in this situation, we say that we have an HA at y equals 0. So the general rule here is if it's bottom heavy, you're going to have a HA at y equals 0. Let's jot that down. Okay, so bottom heavy, the HA is at y equals 0. Now, in a limit question, if x is approaching either infinity or if x is approaching negative infinity, again, we're just focused on the most dominant terms. You could see that it's bottom heavy, so that means your overall limit would be 0. Remember, a limit is simply a y value. In this case, we would want to know what is happening to y as x gets really, really big or really, really small. Okay, here's our next type of example. Again, we have a rational function here. We're trying to investigate, figure out what's happening to y as x gets really big. So the key is to pick out your most dominant terms, top and bottom. Now be careful, your most dominant terms are not always necessarily going to be the first ones you see as you look left to right. In this situation here, we have x to the fourth as our most dominant term, top and bottom. So this essentially means these other terms we can ignore. So this end behavior model would simplify to 2x to the fourth over x to the fourth. So the idea here is we're only looking at the most dominant terms. So as x approaches infinity, if I plug in a million, you're going to have a million to the fourth times 2 divided by a million to the fourth. Well, that x to the fourth term is going to cancel out, so y is approaching 2. Likewise, if you plug in negative a million, y is going to be approaching 2. So we say that we have an HA at y equals 2. So in this problem here, we have equal powers, and when it's equal powers, we say it's just the ratio of the coefficients. So the coefficients are 2 and 1, so 2 divided by 1 would give us the location of our HA. So let's jot that down. So here we go. So again, if equal powers, your horizontal asymptote will be at y equals the ratio of the coefficients. In a limit problem, as x is approaching either infinity or negative infinity, again, we're just picking out the most dominant terms, looking for the ratio of the coefficients, and that's your answer. And finally here, we have a situation that we call top heavy. So if x were approaching infinity, if we were to plug in something like 1,000, okay, this plus 5, this minus 1, it's not going to have much effect on things, so we're really just focused on x cubed over x squared. So it's top heavy because we have more weight in our numerator. Power is greater. So if I were to plug in something like 1,000, notice that the y value is approaching infinity. If I were to plug in negative 1,000, so if x is approaching negative infinity, then in this situation the y value would be approaching negative infinity. So if we were to turn this into a couple limit questions, if x is approaching infinity, we look at our two most dominant terms. We see it's top heavy, which by the way, if it's top heavy, it means there's no HA because the function will not be leveling off. You can see y is approaching either infinity or negative infinity, so it's going to be shooting straight up or straight down forever. So you want to plug in, if it's infinity, plug in something like 1,000, all right, and then you can see that in the end it's going to be positive. And then if x is approaching negative infinity, again, you want to use something like x equals negative 1,000. You go back up here and just write down, as a suggestion, plug in something like positive 1,000. Once again, you would get an estimate of negative infinity for our limit. So if it is top heavy, there's no HA, you want to use either 1,000 or negative 1,000. Pay attention to if your overall answer is either infinity or negative infinity.